Students, next we will move to the problem in the vortex flow. Okay. So, first question I will read. Please follow. Prove that in case of a vortex flow, the rise of the fluid, the rise of the fluid at the ends, rise of the fluid at the ends is equal to the fall of the fluid level at the axis of rotation. What is this meaning? Okay. So, the rise of liquid level at the ends. So consider a cylinder. Okay. So the 3/4 you fill the water or some other liquid. Okay. So now based on the center axis, you give a forced vortex. So what happened? So at the ends, the water level get increases. At the ends, the water level get increases. At mid, that means at the axis of the rotation, the water level get decreases. Okay. So what we have to prove? The rise of water level, at the ends is equal to the fall of the liquid level. Okay. So here consider the cylinder. This is the cylinder, and OO point OO is the uh, initial level of the liquid. Okay. Now this liquid is in static condition. Okay, before applying force. So it is in static condition. This is your initial level. So it is in horizontal. Okay, it is in horizontal level only. Okay, so R is the radius of the cylinder. You can see here R. Okay, R is the radius of the cylinder, and OO initial level of liquid in cylinder when the cylinder is not rotating. Okay, so initial level of the liquid in cylinder when the cylinder is not rotating. Therefore, before applying the force. Okay, next initial height of the liquid. So now consider this is the shape of the parabolic curve after the vortex. After the force applying, a vortex is formed. This is the lower level. That means the AA point, and BB point is the higher level. Okay, at the ends. This is at the middle. So from the initial level OO, the AA level, the distance is we taken as X. Okay, and from the bottom of the container to the AA level, it is called H. Assume that it is H. So initially, before applying the rotational force, what is the height of the water? It is H plus this X. So this H plus this X. Okay. So next, so initial height of the liquid is H plus X. Next, volume of liquid in cylinder. Volume of liquid in cylinder. So since the cylinder is a circular in shape. So if you see in top view, means it is in a circular shape. So what is the cylinder volume? How to calculate the cylinder volume? So area into height. Suppose, so I want up to OO level. Okay, volume of liquid in the cylinder up to OO level. So pi r square nothing but area. So since it is a circular cylinder. Okay, so area pi r square and height of the liquid. So from this diagram you can see what is the height of the liquid. So, so it is H plus X. Okay, so pi r square into H plus X. This is the volume of the liquid in the cylinder. Now let the cylinder is rotated at constant angular velocity omega. Okay, so now I am applying a constant angular velocity omega. The liquid will rise at the ends and fall at the center. Okay, so while rotating, so this is the water level. At the ends it is increasing. The height will be increasing. So but at that center it is fall. Okay, at ends it is rotating as seen our last class, sorry, as seen previous video. Okay, so in forced vortex. So at the ends the liquid level is increases, at middle the liquid level is decreases. Okay, so let x is the rise of liquid at the ends from OO. So x, what is x? So the OA distance, OA distance is nothing but x. This is the nothing but fall of the liquid. Okay, so fall of the liquid. Y, so this x is nothing but fall of the liquid, and y is nothing but rise of the liquid at the ends. So y is nothing but rise of the liquid. That means you taken as it is b. So ob is the rise of liquid at the ends, and oa is the fall of the liquid at the center. So fall I taken as x and rise I taken as y. Okay. So now initially we calculated the volume. Okay. That means before rotating take place. That means fluid at rest. So consider this is equation number 1. Next, after rotation. That means after rotation, what happened? A vortex is formed. Now, under this condition, we have to calculate the volume. So, how to calculate volume? First, calculate volume up to this height. Okay. Next, minus this portion. Okay, na? So, this is like a parabolic shape. This is like a parabolic shape. So, first initially, we have to calculate the height of h plus x plus what is this height? This is y. Okay, minus reduce this volume, this parabolic volume. So we can get the volume of the liquid. So we will do, what is the equation? Volume of cylinder up to level B. So this is the volume of cylinder up to level B. Okay, minus volume of the paraboloid, minus volume of the paraboloid. So initially we have to take up to this BB level volume. So minus this paraboloid. Okay, so next write down the formula. What is the volume of cylinder up to the level? So pi into r square, it is area. Next, height of the liquid up to level BB. Height of the liquid up to level BB. So up to here. Okay. Next, minus volume of the parabola. So how to calculate this volume of the parabola? So pi into r, this is the formula. Please keep it in your mind. This is formula. So pi into r square divided by 2 into height of the parabola. Into height of the parabola. Now you can tell me what is this height? That means from here to here. What is the height of the parabola? It is x plus y. Okay, so from here to here it is y, and here to here it is x. So x plus y. This is the height of the paraboloid. So now write down the equation. So pi r square, same right here. Height of the liquid up to level BB. Now from here to here, what is this height? Tell me. So here h up to this level and x up to O level. So we need up to B. So add y. So h plus x plus y. This is the height of the liquid up to level BB. Minus pi r square by 2 into what is the height of the paraboloid? Height of the paraboloid is nothing but x plus y. So only you have to take only this height. Don't take overall height, only that height. Okay. So now simplify this equation. Pi r square into h. Okay. So pi r square into h. So next pi r square into x plus y. So for simplification purpose, I multiply by pi r square into h one time and again plus pi r square into x plus y minus pi r square by 2 into x plus y. Okay. So next. So this is the equation we already calculated. Now simplify this equation. So what are the common terms here? Pi into r square. So now here you can see pi r square h. You write down this value pi r square h. Okay. So this is as it is. You write down here. So now you simplify this equation. Simplify this equation. So if you simplification means what you got, just think here, see pi r square x plus y. Here also pi r square x plus y. But here 1 is there minus here half is there. So here 1 pi r square x plus y minus here 1 by 2 pi r square into x plus y. So what is this answer? 1 minus 1 by 2. It is plus 1 by 2. 1 minus half. What is the answer? Half. So 1 by 2. So for that only here I written 1 by 2 same as it is the value pi r square into x plus y. So this is the answer. Okay. So I calculated now two volumes. So here one volume, this is one volume, this is called V2, and before that one volume. So now both volumes are same. Both the volumes are same. Okay. So now equate this both volume. What you got? See pi r square h plus x. Pi r square h plus, this is the first equation volume. Next for second equation volume, pi r square into h plus pi r square by 2 into x plus y. This is the second equation volume. So now simplify this equation. What you got? So here you can see pi r square into h multiply by pi r square into h and this pi r square into x. Pi r square into x. So I write down here. Next come to here. Same pi r square into h plus. So pi r square by 2, this value multiplied by this value. Pi r square by 2 into x plus pi r square by 2 into here y. Okay. So now you can see here one pi r square x is there. Here 1 by 2 pi r square x is there. So if this value goes to left hand side means what happened? Pi r square x. So here plus value. This goes to this side means minus value. So minus pi r square by 2x equal to. Okay. Next here you can see pi r square divided by 2. Pi r square divided by 2 into y. Okay. So there is no another term. So what happened? This pi r square h and this pi r square h, it get cancelled. Okay, it get cancelled. These two terms get cancelled because it is lies in the left hand side and the right hand side. So it get cancelled. So finally we get this value and this value and this value. Only these three terms. And this term pi r square by 2x goes to this side means we get minus. So pi r square x minus pi r square x minus pi r square by 2. Okay. X pi r square by 2x equal to pi r square by 2y. So now again I am simplifying. So what is this? Here 1 pi r square x is there. Here 1 by 2 pi r square by pi r square x is there. So what is 1 minus 1 by 2? It is nothing but 1 by 2 pi r square x. 1 by 2 pi r square x. Okay, 1 by 2 pi r square x. So this is this value. Okay, so now tell me what is the other side in this equation. 1 by 2 pi r square y. 1 by 2 pi r square y. Okay, so now you can see here what are the common terms. 1 by 2 pi r square and 1 by 2 pi r square. So what is the final answer we got? So final answer is x equal to y. So from this equation, what you understand? Kindly tell. X equal to y. That means rise of liquid at center equal to rise of liquid at the ends. So it means this OA distance and OB distance both are same. Okay. So before giving the force, before rotation force giving, that level is a constant. Okay. So after rotation, whatever the distance depth of the parabola which is equal to from the level surface which is equal to rise of the level at the ends, both are equal. So from this derivation we conclude that rise of the liquid level at the ends equal to fall of the liquid level at the center. Okay, so this question is very important question. So important 10 mark question. Okay, understand students? Okay, student, next we will move to the next problem. I will read the question, please follow. An open circular tank 20 centimeter diameter. Okay, 20 centimeter diameter and 100 centimeter long. So please listen here, they given in centimeter. We have to convert into meter. Okay, or you can use as it is centimeter also. Okay, so 20 centimeter diameter, that circular tank, and 100 centimeter long, contains water up to a height of 60 centimeter. So the cylinder height is 100 centimeter, but the liquid height is only 60 centimeter. Okay, the tank is rotated about its vertical axis at 300 rpm. At 300 rpm. What do you mean by rpm? Revolution per minute. So the tank is rotated up to a speed of 300 rpm. Find the depth of parabola formed at the free surface of water. So what they asking in the question? Depth of parabola. That means z equal to what? So this is the question. Okay. So now we will calculate. So what is the depth of depth of parabola equation? Omega square r square divided by 2g. Omega square r square by 2g. So this is the equation. So now write the data given. So diameter of the pipe 20 centimeter, radius 10 centimeter. Okay. Height of liquid is 60 centimeter. Speed 300 rpm. Okay. So next, what in the equation, what are the data we need? Omega we need and r we need. Only these two. Okay. What is omega? How to calculate omega? Since it is the angular velocity. Angular velocity. So what is the formula for omega? Means 2 pi n by 60. So this is the formula, 2 pi n by 60. So 2 into pi into n. N is 300 rpm. 300 rpm divided by 60. So this is the angular velocity. Okay. So 31.41 radians per second. So this is your angular velocity. 31.41 radians per second. The unit of angular velocity is radians per second. Okay. So now substitute in this formula. So r we already know, r radius. So once diameter is given, the diameter divided by 2 is the R. So now substitute all the values. So omega is 31.41 radians per second. Okay. And R is 10 centimeter. So either you can convert in terms of meter also. Okay. So meter means how much? Meter means 0.1 meter. Okay. So omega square into R square divided by 2 into 9.81. So G is nothing but 9.81. So finally, we get an answer, the depth of parabola. That means the depth of the parabola. So it is 50.28 centimeter. 50.28 centimeter. Depth of the parabola. See, okay. So it's a very simple question. Once you know the formula means you can easily solve the problem. So this type of question they will ask in 5 marks. So omega square R square by 2G. Omega is equal to 2 pi n by 60. That's all. Okay. So let us move to the next problem. So I'll read the question. Please watch carefully. An open circular cylinder, 15 centimeter diameter. Okay. So the cylinder is 15 centimeter diameter and 100 centimeter long. Okay. Contains water up to a height of 80 centimeter. So the cylinder height is 100 centimeter, but the water height is 80 centimeter. The diameter of the cylinder is 15 centimeter. So just imagine. So here diagram is not given. So I will draw the diagram. So this is the cylinder. So this height is, what is this height? So 100. This height is 100. Okay. So now water is filled up to, this is the water. These are all water. Okay. So the water is filled up to a height of 80 centimeter. 80 centimeter. Okay. So find the maximum speed at which the cylinder is to be rotated about its vertical axis so that no water spills. Okay. So what is the condition? So the condition is, after rotation force given, there is water. Okay, the water should not spills outside of the cylinder. So that means at the ends it should meet at the ends, the liquid should meet at 100 centimeter. So under this condition, what is the speed? This is the question. So are you able to understand the question? Since the initial height is 80 centimeter. Okay, but we don't go beyond this 100 centimeter height. Okay, after forced vortex. So if the water is more than 100 centimeter, it's moved more than 100 centimeter, what happened? The water will spills out. Okay, so it should be avoided under this condition. What is the maximum speed? So what is the unit of speed? It is n. N equal to how much? This is the question. So now we will see one by one. So diameter of the cylinder. What is the diameter of the cylinder given? 15 centimeter. Radius is 7.5. 15 by 2, 7.5 centimeter. Next, length of the cylinder. Length of the cylinder how much? 100 centimeter. Initial height of water how much? 80 centimeter. Okay, student. So these are all the data given. So let the cylinder is rotated at an angular speed of omega, angular velocity. Okay. When the water is about to spill, then using rise of liquid at ends equal to fall of liquid at center. Rise of liquid at ends equal to fall of liquid at center. But rise of liquid at ends. So the cylinder height is 100 centimeter, but the liquid level is initially 80 centimeter. So it should not spill out means what is the balance height? 100 minus 100 minus 80. Okay, 100 minus 80. So this is the balance height. Okay. So fall of liquid. So if rise of liquid 20 centimeter means fall of liquid also 20 centimeter. Okay. So our condition is it should not spill out. Suppose if if you give more rotation means what happen? The water level at the ends will greater than the 20 centimeter. So automatically the water will spills out. So our condition is the water should not spills out. Okay. So next, rise of liquids on 20 centimeter. Also fall of liquid also 20 centimeter. Now, what is the height of parabola? Okay, height of parabola is 20 plus 20. So 40 centimeter. Okay, height of parabola. So x plus y. X plus y is equal to z. X, Y, Z. Simple. Okay, X, Y, Z. X plus Y is equal to Z. Okay, so now what is the Z value? 40 centimeter. That means the overall depth of the parabola is 40. Is 40. Okay, so now we know that Z equal to omega square R square by 2G. This is the formula for the calculation for the depth of parabola. So Z. So here what are the unknown value? Only this omega. Only this omega. So Z equal to 40 centimeter, which is equal to omega square into R. R is what is R? 7.5 centimeter. So omega square into 7.5 square divided by 2 into 9.81. So this is 9.81. Okay, 2 into 9.81. So from this equation, 40 equal to omega square into 7.5 square divided by 2 into 9.81. So from this equation, we easily calculate the omega. So omega is equal to 37.35 radians per second. 37.35 radians per second. Okay. So now speed is. So once you calculate omega, so the speed is hidden. So where is hidden? In the omega formula only. Okay. So this n value. So our ultimate aim is to calculate the speed. That means n value. Okay, na? So this n is hidden in the omega formula. So there are two unknown values is there. Omega also we don't know and n also we don't know. Okay. So first you must calculate omega, omega. And from this you calculate n. So omega, what is the omega? 37.35 radians per second. Okay. So n is equal to 60 into omega. So this 60 goes to this side means 60 into omega divided by this 2 pi comes to denominator 2 pi. 60 into omega divided by 2 pi, which is equal to 60 into omega 37.35 divided by 2 into pi. So from this equation, n speed of the rotational force is equal to 356.66 rpm. Okay, the unit of speed, that means n is equal to rpm. So 356.66 rpm. Okay, so first understand the question. So sometimes they will give like this. The water should not spills out. Should not, that no water spills. Okay, So under this condition, first you have to write this some assumption. Okay, write this assumption. So once you write this assumption, you can easily calculate the z value. Okay, so x, this is the rise means y. Okay, this is fall means x. So this x and y. So x plus y is equal to 40 centimeter. So z equal to 40 centimeter. So using the relation omega, z and omega is z equal to omega square r square by 2g. So once you found omega, so using this equation omega equal to 2 pi n by 60, we can easily calculate the n. That means speed of the rotation. Okay. So I hope all of you understand this two problem. So these are very easy problem only. Students, now we will move to the fourth problem. Okay. So I'll read the question. Please follow. An open circular cylinder 15 centimeter diameter and 100 centimeter long contains water up to a height of 70 centimeter. So please see this diagram. A open circular cylinder is there. Diameter is 15 centimeter and height is 100 centimeter long. Contains water up to a height of 70 centimeter. That means at rest level. Okay, before the vortex, 70 centimeter height. Find the speed at which the cylinder is to be rotated about this vertical axis. Okay, students. So now you carefully listen to the question. So this is as per our previous problem. Only one smaller change. So further you read so that the axial depth becomes 0. What is this meaning? Axial depth becomes 0. So here you can see the parabolic curve. So here x is not equal to y. X is not equal to y. Okay. So at center, the parabolic curve, the vertex parabolic curve touches the bottom of the cylinder. Okay. So what is that z value? So here you can see it touches the upper end of the cylinder. Okay, at ends, and at lower level it touches the parabola touches the at the bottom level of the cylinder. So this is the condition for the axial depth become 0. Axial depth become 0. So in the examination they will not give the diagram. Okay, in examination they will not give diagram. So based on this question only you have to write the diagram. Okay, in the question if they given axial depth is become 0 means you draw the diagram like this. So first draw the cylinder and draw the cylinder height and mention the initial water level and draw the parabolic shape up to the bottom. So finally z equal to 0. Okay. So here also they are asking speed n. So now you write diameter of the cylinder 15 centimeter and radius 15 by 2 7.5 centimeter. What is the length of the cylinder? Length means here height. Okay, 100 centimeter. Initial height of water equal to 70 centimeter. When axial depth is 0, the depth of paraboloid equal to 100 centimeter. Okay, so this is the condition. This one only you have to keep it in your mind. When axial depth is 0 means the depth of paraboloid equal to 100 centimeter. Next, using the relation. So in this problem also, as per previous problem, there are two unknown values. One is this n and other one is this omega. There are two unknown values. So z equal to omega square r square divided by 2g. Using this relation, using this formula, first to find out omega. Okay. So 100 equal to omega square R square. What is R square? 7.5 square divided by 2 into 9.81. So from this omega square and omega, we got finally 59.05 radians per second. Okay, 59.05 radians per second. So this is the omega value. So next, speed. So once you find the omega value, we can easily calculate the speed. So using this relation, omega is equal to 2 pi n by 60. So n is equal to 60 into omega. So this goes to here and this 2 pi goes to denominator. So 60 into omega divided by 2 pi. So from this we got 563.88 RPM. 563.88 RPM. Okay, student. So, if you understand the question correctly, means the formula is formula and direct substitution only. It's very easy. So, most of the students, what they did in the examination means they didn't understand the question properly. Okay, so you can see here in this problem, axial depth becomes 0. So, under this condition, z equal to 100. So before problem, you can see what is the condition they given. There is no water spills. There is no water spills means rise of liquid at ends equal to fall of the liquid at center. You have to apply this condition. So based on this condition, you must calculate z. Z equal to x plus y. So rise of liquid and fall of liquid. So once you found, so in both the cases, initially we have to find z. Okay, and omega. Finally, n. Okay, so this type of question is very, very important question in forced vortex. Okay, now student, I hope all of you understand this 4 important problems in the vortex flow. Okay, so one more problem is there that we will see in the next class. Okay, students. So thank you very much for your understanding. Once you go through the problem once again. Okay, I will share the video link. Thank you.